Okay, good afternoon. Today we are looking at transformations of functions. This is CP 70, everybody said, so 1114. And so we're looking at transformations of parent functions. And these are rigid transformations. That's what we call them, rigid transformations. And what that means is the basic, the shape of the parent function remains unchanged. And all we're doing is taking a basic shape and sliding it left, right, up or down. And so all of these functions you could graph in your graphing calculators, but we're not going to do that because our brains are faster and better.
All right, I'm not sure if you heard what you just said, but you said my brain's faster
and better. So the first thing what you want to do is note that we have a few parent functions here. These are great parent graphs. We have y equals the absolute value of x, y equals the square root of x, y equals x squared, and y equals x cubed. These are four basic parent functions. Basic because you'll notice that there are no extra additions here. We don't have that -3 or the -5 or that negative out in front. And so it's a very basic function. All of these are parent graphs, and you should know the basic shape of them. Does anyone know what the absolute value of x looks like?
It's like a point.
It's a v. Absolute value v. Yes, always, always. If you didn't know what something looked like, how do you graph stuff without a calculator?
Oh, you plug in x.
You plug in numbers. You plug in numbers for x. So we would plug in like +1. The absolute value of +1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. The absolute value of 0 is 0. The absolute value of -1 is 1. The absolute value of -2 is 2. So we get this absolute value v graph. And this is the basic shape. It really is just a v. And you can always graph by plugging in values for x and simplifying, right? So we could do a little xy chart and blah, 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 but we don't want to do that. So I'm going to graph with lots of colors. So look at the number 2 there. What is the extra addition on there? What do they have with it? -3. What do you think that's going to do to the function? It shifts at 3. Shifting at 3 is right. My question is it 3 units to the left or right or up or down? No.
No.
Okay, so now I want to ask you a different question. Actually, it has nothing to do with the absolute value, so we don't have to worry about that. So is that 3 on the? Would you say it's on the inside or the outside of the function?
Wait, I don't know.
Well, let's look at the 5. Compare that to the -5. Would you say the 3 is on the inside or the outside? Okay. The 3 is on the inside. That 5 is on the outside. Very, very good. Okay. When things are on the inside of the function, they're inside with x. You can see that it's inside the absolute value. Yeah, that's the function. The absolute value is the function. When numbers are on the inside of the function, it always affects the x values. It's inside with x. So it's going to affect the x values or the x-axis. And the x-axis runs left and right. So whenever you have a number on the inside, it affects the x values, and the x values move left to right. Okay. So now that we know the 3 is on the inside and we know we're moving left and right in the x direction, here's your guess. Does it move left 3 or right 3?
Right.
Right 3 units.
So it always moves right?
Unless it's on the outside.
Unless it's on the outside.
Yeah, so this is very similar to what we did yesterday with the x minus h quantity squared. It's sort of the opposite. That minus is sort of part of the formula. This actually goes right 3 units. And so what happens here is I just get to take these points from my parent function, my base graph, and I get to just count 3 spaces to the right. 1, 2, 3. And replot my points. Just a few is enough. We don't have to go crazy. And that's number 2. All right. This is the transformation, and that's a good thing to write down. All right. So that -5 on number 3. Is that -5 on the inside or the outside? The outside. That is on the outside. Stuff on the outside must affect not the x's, but the y values. Our y-axis is our vertical axis. It goes up and down. And so numbers on the outside move us up and down. It is a vertical shift. Now that you know it's going to go up or down, do you think it's going to go up 5 or down 5? Down 5 units. Down 5 units. So, in general, everything with x is inverted. I can talk about y. It has to do with solving for x. But everything with x is always opposite of what it looks like, inverted, okay? Everything that affects y is straight up, does what it looks like, okay? So this is going to go from our base graph again and take our base graph and just shift it 1, 2, 3, 4, 5 units down. This is all we're doing today, ladies and gentlemen. Okay? Which direction, like the red one here moved to the right? So because the 3 was inside with x, it moves in the x direction left and right. So just like yesterday when we had the formula with x minus h and you had to change the sign, the negative. Yeah, the negative is part of the equation. Yeah. So everything with x is opposite, everything with y stays the same. So did culinary make salsa today? Pico de gallo. So it's,
and then I also made fajitas.
I heard it's fajitas.
Hey,
I'm
it's
gonna
been
be
like
honest,
smelling up my
Those
class
chips
for the
are
past
the
like
best.
3 hours. Okay.
It's okay.
Tortillas.
Oh, we still have one more to do. Okay, here we go. All right. Is it taken? Similar. All right, here we go. Last one here in this set. What's the difference between number 1 and number 4? The negative. There's a negative. Would you call that negative on the inside or the outside?
Outside.
The outside. Since it's on the outside, guess I'm not going to use that color. All right. Since it's on the outside, and you'll notice that it's in front, this is really thinking it's like -1 times our absolute value of x graph, okay? That out in front there is being multiplied by -1. Because it's on the outside of the function, outside of those absolute value bars, okay? Then it is affecting, just like we said, it's on the outside, it affects the y values. But in this case, it's taking those y values and literally multiplying them by -1. It is taking those y values and making them the opposite. So if
number 1, so it's going down.
yes, it flips it, ladies and gentlemen. You know that. It's called a reflection.
Reflection.
A reflection over the x-axis, which is totally weird. So it takes my blue graph and it changes this y value of +1 and it flips it over the x-axis. It becomes -1. Positive 2 flips and becomes negative 2. And so we get the upside down V, downward V. Downward dog. Okay.
Wow.
All right. That is a reflection. I love when you call that a vertical reflection. Okay? All right. Now we're going to go faster.
Yeah. Water.
All right. Yesterday we did parabolas in standard form. This is essentially the same thing. So we know our base graph here. What shape is y equals x squared?
Parabola.
Parabola. We know it's an up parabola. It passes through 0, 0, 1, 1, and 2, 4, and is reflected across the axis of symmetry. Did I ever tell you guys about my Algebra 2 teacher?
No. Please.
Mr. Smith? Oh, man. Yeah. So we did parabolas, and like if my graph wasn't perfectly smooth, you'd lose points. If it was a little too sharp, you'd lose points. But when he would pass back our tests, he'd sit up at his desk, which was at the front of the class, and he'd pass them out one at a time and make sure he commented every time. And so he'd be like, Christy, well, we're glad you passed. And like, Rajesh, and by the way, Rajesh was like, brilliant. Rajesh, even Amanda beat you. That was my favorite.
Oh my god.
Yeah, that was awesome. So I actually was working at my high school when he retired. And so I was invited to his retirement party. Well, this was a couple years after he retired, actually. When another colleague retired, and so we were both there. And he walked up to me. He's like, "I remember you." I was like, "Yep." And he's like, "You became a math teacher." I'm like, "Yeah." And he's like, "Did I ruin your life too?"
What? Oh no.
All right. So.
Oh my God.
Okay, ladies. That's my story of my most
You really
awesome
said that?
teacher. Okay.
See, those are the people who inspire. Did he inspire you to become a math teacher?
No. He did not. No, he was scary. He made math very scary. I mean, I did really well, but I was scared.
Maybe that's why. Maybe that's why.
All right. Number 6 here. Is the 5 on the inside or the outside? Inside. Does that affect X's or Y's? X's, which means it's going to go left 5 or right 5? Left 5. Remember, everything with X is always sort of opposite. 1, 2, 3, 4, 5 units to the left. And then copy your shape because the shape does not change. It slides left and right. All right. Number 7. Ooh, how many transformations do we have on number 7? 2 transformations. There are 2 numbers changing things up here. So that 3, is it on the inside or the outside? Inside. Does that affect X's or Y's? How does it shift left or to the right? Right. I'm going to spell right correctly. Right 3. The 4, is it on the inside or the outside? Outside. Does that affect X's or Y's? Which means it's going to go up 4. So again, from my blue graph, gentlemen, I am going right 3 and up 2, 3, 4, which is how the vertex becomes positive 3, 4. All right? And that's number, is that 7? Right 3, up 4. It takes our parent function and just slides it 3 units to the right and 4 units up. Okay? All right, ladies and gentlemen, number 8. Number 8. We have how many transformations here?
2. Well, 2 and
Two.
then we're reflecting.
Well, 1 and a reflection. So 2. That's 2. Yeah.
Oh, yeah. The -4.
Okay. So, the 4, is it on the inside or the outside? Inside. So how does it shift? Right 4 units. Good. And then what does this, that negative,
Reflection.
has a reflection. A reflection over the x-axis. I call it a vertical reflection. So what's happening here is I'm taking my base parent function, my blue graph, and I'm going to shift it right 1, 2, 3, 4 units. But then it's no longer opening up. Now, because of the negative, it flips and is opening upside down. It's making all of our y values turn to their negative. All right, questions on those? It's like a lovely rainbow of math. Okay, here we go. We've talked about the square root function, I believe, in this class. I've mentioned it before. Does anyone remember what I called the square root?
Squiggle.
Squiggle.
Oh.
S's.
Swoosh. Oh, I was close.
Yeah, the square root swoop. So let's go through the points. Again, you can always find what values they are by plugging in numbers for x. Can I plug in a negative number for x? If I want to get imaginary solutions, I sure could have, but that won't help me graph. So I could plug in like 0. Yeah, plug in. What's the square root of 0? 0. And I could plug in 1. What's the square root of 1? 1. And I could plug in 4. What's the square root of 4? 2. So we have 0, 0, 1, 1, and 4, 2, which are great points. Also, 9, 3 is another great point. Square root of 9 is 3. So this is our square root swoop function. What's the domain of this function? 0 to infinity. Yeah. Remember, domain asks how far to the left and how far to the right does the graph go. So what's our furthest left point? 0. How far to the right does that arrow go? To infinity. So we're going to use a bracket at 0 because we do have a value there. What's the range of this function? 0 to infinity, yes. Again, range talks about the y values. So we look at our y-axis and we say, what's our lowest y value? 0. And that arrow goes up forever as well. All right, just a little reminder there. Okay, number 10. How many transformations do you have on number 10? 2 transformations. The 4, inside or outside? What does that do?
X.
Left 4, good. The 5, inside or outside? Outside. So what does that do? Down 5. So I'm going to take my parent function and I'm going to slide it left 4 units and down 1, 2, 3, 4, 5. Left 1, 2, 3, 4, down 1, 2, 3, 4, 5. 4, 1, 2, 3, 4, 5, and you don't have to. All right, there we go. That's number 10. Way too much fun. Good thing it's a room full of nerds. It does what it says. No changes.
So you put in a number and then 5 is what you do.
Oh, yeah.
You said so much.
Okay. Number 11. What does this thing in front do? -1 out in front. What's that going to do to our y values?
Oh, make it go down.
Yeah, flip
Oh, I
or
was gonna say
reflection.
green too.
Yeah. So what it does to my blue graph, the 0, 0 stays the same, but 1, 1 flips and becomes 1, -1. It reflects over the x-axis. 4, 2 is going to reflect across the x-axis and become 4, -2.
Ooh. Oh, wow, you must have both done that. I'm just gonna wear that picture.
Whoa, yeah.
It's called a hyperbola.
Hyperbola.
This is
All right.
hyperbola.
Parabola.
Ooh, number 12 is very tricky.
Ah. Ah. God.
All right.
What?
So
It goes down so they're like you know when it.
What's a negative? What's a positive?
take a second and see if you do it correctly. This always takes me a while to do. Don't use your calculator.
I can't draw, so I did my best.
Joe's not figured that out. Yes. I drew with his pen, so I can't erase it. That's an L.
Look what I have.
All right. So when we do transformations, you'll notice this one is more challenging because how many transformations are there?
4.
There's 3. We got the extra 3 in here. We got the 2, and we have a negative out in front. So there's 3 transformations. And the problem with doing transformations by hand is that order is super duper important. Okay. And so we observe order of operations. So I'm going to do this particular one in 3 steps because there's 3 transformations. All right. And I'm going to start. The first thing I'm going to do is because of order of operations. What does order of operations tell us to do? Parentheses first, right? All right. So parentheses, meaning inside our function here are some little invisible parentheses. So I've got to work that inner transformation first. So what is that 3 doing to my graph? Okay, so it's going to move right 3 units. So I'm going to take my blue graph and I'm going to shift it right 3 units. 1, 2, 3. All right, that's my first transformation. I made it dotted. It's not really there. Okay. All right. So now I have 2 more transformations. I have the negative, which is like a -1. And then I have that +2. So the question is, which do we do first?
Positive 2.
It does matter.
Positive 2. Negative.
Why do you think? So that's correct. Why do you think you would do the reflection first?
It's directly connected to something instead of being addition to
Yes. So this is this. Yeah, the second step is to do our reflection because it's really -1 times our y values. We are multiplying our y values by a negative and it's going to flip them. We have to do multiplication before we can do any addition or subtraction. Okay? Order of operations. Parentheses, multiply, and then add, subtract. So now here on my little pink graph, this 0, 3, 0 stays here. What happens to this point at 4, 1?
Negative. Reflection.
It's a vertical. that positive 1 turns to a negative 1. And so my graph got flipped upside down. And then the very last thing that happens is the up 2. So now I can take it and shift up 2.
Hey.
Yeah.
It's for horses.
Did you do the reflection first?
No.
Okay. So then you actually executed it incorrectly. So here's if you were to take, if you shifted the blue graph first, right 3 and up 2, yes, you'd have the same point. Your graph, I wish I had one more color here. Would, look here, okay. Looks like this, right? If you just shifted the right 3 and up 2. But if you were to execute a reflection, it takes the y value and makes it the opposite. Yeah, so you just flipped it around itself, which is not a reflection. Yes. So, but incorrectly. I mean, that's the problem. So at any rate, that's the reason why. So it is important which order you do these in. We do multiply before we do that slide up or down. All right. Cubic. A cubic is a squiggle. Yeah, it's
It's cancer. I struggle to draw that negative one so bad. Like I just can't get my hand to do it.
all right. The cubic function goes through 0, 0. 1 cubed is 1. 2 cubed is 8. It's very steep.
What?
Yeah, it's a very steep graph. So it's something like this. This is our cubic function. It's important. I always do the 3 dots, but it's important that it's not a line. It's a very different function than our line y equals x. So make sure that you've got your heading towards 2, 8 is what the point is, and negative 2, negative 8. Okay. Alrighty. Is the 3 on the inside or the outside? Inside, which means it's going to do what? In the x direction, right 3 units. Very good. Right 3 units. All right, number 15. A reflection. Yes, this is a reflection. A reflection. So, well, no, it doesn't turn your hand that way. It actually flips vertically. So this point, which is at 1, 1, flips and becomes 1, negative 1. And this point, which is at negative 1, negative 1, flips and becomes negative 1, 1. So it flips in a vertical line, not spinning around the other way.
Are you going to grade us on not being able to draw them?
It is, yes, and that's interesting that you said that, Noelle. You get the same thing if you flip horizontally. That's because this is symmetric about the origin, which flips vertically and horizontally. What? This is 15.
You know, the only people that even use that don't have one.
Yeah.
It's so funny.
All right, last and certainly not least, number 16. How many transformations are there? 3 transformations. So we need to take them in order. What's the first transformation? Inside, we need to go left 4 units. So I'm going to take my blue graph, 1, 2, 3, and move left 4 units.